Hello students, today we're going to look at 7.1 in algebra and the title is Parallel and Perpendicular Lines. And we're going to look at some qualities of parallel and perpendicular lines that may help us in the future. So the first thing I want you to do is look at the two purple lines. Now it is not imperative that you copy down this graph, not necessary for right now, but I do want you to copy down the things that are right next to the graph. Okay, so first of all, we're just looking at the two purple lines. Okay, and you can tell the two purple lines are parallel because they never cross each other. So let's look at them and let's see if we can figure out something about parallel lines. So first we're going to write parallel. And don't you love it how the L's are parallel and parallel? That's how it helps me remember how to spell it. In parallel lines, I have one equation is y equals 2x. And the other equation is y equals 2x minus 6. Well, what do you know about both of those equations? Give you a second to look at it. You probably came up with this, but you notice that the slopes are the same because I have the equations written in slope-intercept form, y equals mx and y equals mx plus b, and both of them have the same slope. So something that you need to know about parallel lines have the same slope. All parallel lines will have the same slope. That's a way to know if the equations are parallel. Look at the slope and see if the slope is the same. Now sometimes you might have it in some crazy form like standard form or point slope form or whatever, and you have to find the slope out of all that. That's fine. Just make sure when you find the slope, you see if the two slopes are the same, the lines are parallel. Now let's look at the purple line compared to the orange line. And I'm going to focus on y equals 2x just because it's easier to deal with in our problems. So with perpendicular, I guess I could spell it correctly. With perpendicular lines, that is so bad. We have perpendicular lines. The first line is again y equals 2x. And the lines that's perpendicular to that, and just in case you forgot what perpendicular means, is perpendicular means where they cross and form right angles. Okay? So you can see that this is a right angle, that's a right angle, here's a right angle, and here's a right angle, where the orange line and that purple line cross. So the equation for the purple line is y equals negative 1/2 x. So what do you know about those slopes? This one's a little bit more difficult to kind of figure out. What we need to know about perpendicular lines is their slopes are opposite reciprocals. Probably need to define reciprocal. Reciprocal means to flip the fraction. Okay? Opposite means if it was positive, then it's going to become negative. So notice that my slope for the purple line is y equals 2x. If I take that 2 and I flip it, well, how can you flip it? There's only one number. Well, remember, every fraction can be written over 1. So if I have 2 over 1 and I flip it, I get 1/2. But then I take that 2 over 1 and I know it's positive, so then I need to make it negative. So the negative reciprocal is negative 1/2. So y equals negative 1/2 x is a line that's perpendicular to y equals 2x. So once again, just to clarify, parallel lines have exactly the same slope and a different y-intercept. Perpendicular lines have an opposite reciprocal slope, and it doesn't matter about the y-intercept. Okay? Make sure you have that information down, and we'll do some more examples in just a second. So just in case you didn't have it written down, let's make sure we have it written down. Parallel lines, same slope, different y-intercept. Perpendicular lines, opposite reciprocal slopes. And the y-intercept does not matter. Let me scoop that over just a tad so we can see everything. So just in case you didn't have that down, make sure you know that parallel lines have the same slope and a different y-intercept. Perpendicular lines have an opposite reciprocal slope, and the y-intercept doesn't matter. So let's say we're given a problem that says to write the equation of a line that's parallel to something and passes through a point. So let's take this example to use. Let's say the equation is y equals 3x minus 7, and it passes through negative 3 comma 4. And what I need is an equation of a line that is parallel to this line, but passes through this point. Okay? Because it's parallel, we know their slopes are going to be the same, so that I know that, excuse me, the slope of my new line is going to be 3, because the slope of this line is 3. So I know m is going to be 3. Well, I know m is 3, and I know it's going to pass through negative 3 comma 4, which is an x and a y. So I have an x and a y and an m. The only thing I don't have is, yes, b, and so I need to plug in what I know to find b. So I know, and I'll just start with the formula, y equals mx plus b. I know that y is going to be 4, m is going to be 3, x is going to be negative 3 plus b. So I just took my slope-intercept form, plugged in what I know, the m, the x, and the y, and now I'm going to solve for b. So 4 equals negative 9 plus b. So I've got to add 9 to both sides, so 13 equals b. So now I know my new equation is going to have a slope of 3 and a y-intercept of 13. So my new equation will be y equals 3x plus 13. Just to recap, use what you know to find out what you don't know. I know that the slope is 3. I know that it's going to pass through this point, so I can use that for my x and my y, plug it in to find b, and then create my new equation with a slope of 3 and a y-intercept of 13. So now let's look at a different problem, and that is I need to write an equation in slope-intercept form of a line that's perpendicular to this line, but passes through this point. Okay, so we're perpendicular. So first of all, I have to find my old slope. Well, my old slope is 1/2. So we know if it's going to be perpendicular, I need the opposite reciprocal. So the opposite reciprocal, the reciprocal of 1/2 is 2 over 1, and the opposite of that is negative. So we know that my new slope is going to be negative 2. I just took the old slope, flipped it, and made it opposite. Now I have to figure out what my b is. Now I have a slope and I have a point, so now I need to find out what my b is. So I'm going to plug it into y equals mx plus b. I'm going to use my new slope. So I know that 9 equals negative 2 times 2 plus b. Y, m, x, and then I'm looking for b. So 9 equals negative 4 plus b. And now I have to add 4 to both sides to get b by itself. Oh look, we come up with 13 again. So b equals 13. Now I know my slope. I know my y-intercept. So now it's time to plug in the equation, or make the equation. So y equals negative 2x plus 13 is an equation of a line that is perpendicular to this line, but passes through the point 2 comma 9. Once again, I'm taking the information that I know to find out what I need to know. I knew the slope was 1/2, and I found the opposite reciprocal of that, which is negative 2, found b, and plugged it into my equation. And here are your 2 practice problems for this video. Number 1 says, write an equation in slope-intercept form that is perpendicular to y equals 3x minus 7 and passes through negative 3 comma 4. Perpendicular. Number 2 is write an equation in slope-intercept form that is parallel to y equals negative 9x plus 81 and passes through negative 2 comma negative 8. Again, parallel. Once you finish those 2 practice problems, take a picture of them, submit it through Edmodo using the Turn In button.